Now let's look and see how a magnetic field can be created by a moving current in a wire. What we have here is a wire connected from one side, going over and over this to the other side of our piece of apparatus. So it's coming straight through from the paper. A DC power supply that's right here. Once again, iron filings. Turn on our power supply. So we have direct current right through our wire. If we put iron filings on the top, tap our apparatus, you'll note that there are concentric circles around our wire, and that is because the magnetic field that is created by that wire, if we use the right-hand rule, magnetic field up, iron filings are going to curve around just like this. We know this. Now, this has some very curious effects with also the single loop, which is what we have right here. We reconnect our DC power supply, now turn it on. Put the filings on top. Once again, tap. You'll note that we now have small rings around each one of these pieces, but that we started to have a field growing this way now too. We go ahead and turn off our power supply and use a solenoid and a toroid. We can see what can happen when we have multiple loops. Ah, yes. You can see the classic shape occurring right now. Each one of these individual wires actually has a small loop of current around it, but in the middle here, they all add up so that you get the iron filings running in a straight line through the middle of this. If you do the same thing with a large toroid, that's what we have here. Let's look at this classic shape. Very easy to see. By having all these loops, we have an additive factor so that the field lines are now running in concentric circles, and we have small circles around each one of these pieces of wire coming through the plastic. Zero magnetic field in the center.